last video, we have learned a puzzle, right? We solved a puzzle where that person was searching for the gems, for the precious stone, and his mother kept a puzzle for him, and even for the relatives also. So now I hope you all remember this. So in this video, we are going to study about square numbers, and then we will see what are the uncovering patterns and properties of square numbers. So are you all ready? Yeah, so let's start. Okay, so what are the square numbers? We know that the number of unit square in a square is the product of its side. If we see this is a square. Now here these all are small squares which has side 1. So that is why these are called unit square. So if suppose we want to find the area, it means what we will do? We will find the product of its side, right? So this product will give the area. Are you all getting? Okay. Now let's see how. So basically, visualize a square, if you visualize a square, then what you see? You see that the number of unit squares that form a larger square is the product of equal sides. Like for example, this is one square. Okay, if I want to find its area, 1 into 1. One square, it is written as 1 square equals to 1. For this square, if I want to find the area, okay, then here what I can write? I can write it as, see here, you can see it is 2. And here also, it's 2. Right? So what it is basically, it is 2 into 2. So that is 2 square, 4. So if I want to find area of this, then here you can see it is 3. And here also it's 3. Right? So its area will be 3 into 3, 9. Right? So basically this term square, it is originated from the area of geometric square. You have seen here, right? So I hope you understood why these numbers like 1, 4, 9, why these numbers are called square numbers. Okay, so now, and how we write this? We write like 1 is 1 square, 2 square is 4, 3 square 9, 4 square 16, 5 square 25. Okay, like this we write. It means in general what we can say, if we multiply a number by itself, like n into n, we will write it as n square. So this n square is called a squared number. Read it as n squared. Now can we find only square of the integers, or can we find the square of fraction or decimals? So if suppose we want to find the square of fraction, same 3 by 5 whole square. So it is nothing but 3 by 5 whole square is written as, you can see here what? 3 by 5 into 3 by 5. So how we will write? 3 3s are 9 and 5 5s are 25. So 9 by 25, like this we can write. Similarly, if you want to find the square of 2.5, what you will write? You will write 2.5 into 2.5, which is nothing but 6.25. Okay, now further it is given that the square of natural numbers are called perfect square. Okay, so like for example 1, 4, 9, 16, 25, these all are called perfect square. Okay, sure. Now some pattern and properties of perfect square. So for pattern and properties of perfect square, first of all we have to fill in this table. So in this table, 1 square is 1 given, 2 square 4 given, 3 square 9, 4 square 16 and 5 square 25, it's given. Now these all you have to fill and don't ask anyone. Okay, fine. So start writing quietly. Started? Okay, chalo, let's start. 6 square, 36, very good. 7 square, 49. 8 square, 64. 9 square, it's 81. 10 square, it's 100. 11 square, it's 121 written. 12 square, it's 144. 13 square, 169. 14 square, 196. 15 square, 225. 16 square, 256. 17 square, it's 289. 18 square, 324. 19 square, 361. 20 square, it's 400. Similarly here, you have to fill and you have to write the squares like 21 square, 22 square, 23 square, like that you have to write. Then, are you observing something here? Can you see some pattern here? Okay, now let's see. What are the secret code that every perfect square follows? Okay, so every perfect square follows a distinct set of rules. So let's start. Let's decode them. So, what pattern you notice? Just now you have seen we have written the squares. What pattern you notice? You just share your observations and make conjectures. Okay, so let's see what pattern we observe here. So the first clue which was given is always the last digit. Okay, so now here you can see as there we wrote the 20 perfect squares, first 20 perfect squares. So we will notice that only. So here 1 square unit digit or last digit is 1. Similarly 11 square last digit is 1. 2 square last digit is 4 and 12 square last digit is 4. 3 square last digit is 9 and 13 square last digit is 9. Like that if you see, then what you have observed here, you can see clearly that in the square numbers, 0, 1, 4, 5, 6 and 9, these 6 digits are coming as last digit. Okay, and you know that in maths we have total 10 digits. So only these 6 digits are coming as last digit. So what about these remaining ones? So we can see 2, 3, 7 and 8. These are not at all coming for a single square number. Right? So these are not at all coming for a single square number. So what we can say here? We can say that if a number ends with 2, 3, 7 and 8, right? If a number ends with 2, 3, 7 and 8, it will never be a perfect square, right? Okay, now let's see the next one. If a number ends in 0, 1, 4, 5, 6 and 9, it is always a square number. Is it? Because just now we have seen that the number which are ending with 0, 1, 4, 5, 6, or we can say that all the squares numbers are ending with 0, 1, 4, 5, 6 and 9. But is it always true? Let's check. If you take 16, which is 4 square, if you take 36, which is 6 square. So these both square have 6 in their unit place, and these are the perfect square number. But if you take 26, which has 6 at unit place, but it is not a perfect square. It means this condition is not always true, but it helps us to tell when a number is not a square number. It means if a number ends with 2, 3, 7 and 8, we can definitely say that it is not a square number. Now, write next 5 numbers such that you can determine by looking at their unit digit that they are not squares. So obviously you can write any 5 numbers which are ending with 2, 3, 7 and 8. You will get your answer. Now Let's consider the square numbers ending in 6. So here we have taken 16, which is 4 square, 36, which is 6 square, 196, which is 14 square, 256, which is 16 square, 576, which is 24 square, and 676, which is 26 square. Okay, so which of the following numbers have the digit 6 in their unit place? It means here you can see if it is ending with, if it's square, like if it is a square of a number which is ending with 4 or 6, then we can say in its square it will end with 6 always. Now here you can see it is ending with 8, so obviously it will never end with 6. 4, yes, this square will end with 6. 6 at last, yes, its square will end with 6. Here 6, yes. 4, yes. 82, no. Okay, so now let's see the next. Okay, now there are more patterns in observation. Okay, first pattern you have clearly seen about the last digit. Now the next pattern says number of zeros. Okay, what next pattern says? Number of zeros. It means if a number has 1 0 at last, its square will have 2 zeros, double. Okay, like 10 square is 100, 20 square is 400. Similarly, if a number has 2 zeros at last, its square will have 4 zeros at last. Right? It means what we can say, a number can only be a perfect square if it has an even number of zeros at the end. And if it has odd number of 0, no, it will not be the perfect square. So here you can see with 1 0, with the square number we have 2 zeros. Here 2 zeros, with the square number we have 4 zeros. So if a number contains 3 zeros at the end, how many zeros will its square have at the end? If it is 3, double of 3 is what? 6. So yes, its square will end with 6. Now let's see the next. What do you notice about the number of zeros at the end of a number and number of zeros at the end of its square? You must have observed something here, right? We were discussing, will this always happen? Can we say that a square can only have an even number of zeros at the end? Yeah, we can say. Okay, now next, some perfect squares and odd numbers. What's the relation between perfect square and odd numbers? Okay, so now the relation between consecutive squares. So the first square number is 1, the second square number is 4. If we find the difference, we can see it is 3. If we find the difference of second and third square number, it's 5. Third and fourth square number, it is 7. Fourth and fifth square number, it is 9. It means what we are getting? We are getting consecutive odd numbers. So what we can say? We can say if we add consecutive odd numbers, we will get the perfect square number. For example, 1, 1. Now 1 and the next odd number is 3. So if we add 1 and 3, we will get 4. If we add 1, 3 and 5, we will get 9, which is third square number, and like this we can get. Okay, so here you can see it is clearly framing a square, right? Now, do you remember the pattern from grade 6? You were learning something like L shape. So we see that the sum of first and odd number is n square. Okay, so this is the formula which you have to learn, that sum of first and odd number is n square. Alternatively, average square is a sum of successive odd numbers starting from 1. Right? Sometimes see what happens, argument and reasoning can be presented without any word. Visual proof can be complete by themselves. Okay, chalo. Now let's see, we have one more pattern here. Right? So what that pattern say? So that pattern says, so Also, we can find out whether a number is a perfect square by successively subtracting odd numbers. What we have to do? We have to subtract successively odd numbers. Okay, so let's subtract and check. So first of all, we'll check for 36. So here, okay, so we have to check for 36. So before 36, let's check for 25. Then we'll come to 36. Now here 25. So from 25, we'll subtract the first odd number, which is 1. So 25 minus 1, 24. Right? Now from 24, next square number, next odd number, which is 3. We'll subtract, we'll get 21. Next 21 minus 5, 16. Then 16 minus 7, 9. And then next odd number is 9. 9 minus 9 is 0. It means if you are getting 0 at last, the number is a perfect square number. Okay. And then how many steps it took, that will define its square root. This is called square root. 5. So as we can see here, 5 numbers. So this is the square root of 5. Now let's check this with another number, 38. So from 38, first odd number is 1. Subtracted 31. 31 minus 3, 34. 34 minus 5, 29. 29 minus 7, 22. And 22 minus 9, it's 13. And 13 minus 11, it's 2. And then after 11, next odd number is 13. So 2 minus 13 is minus 11. We are not reaching at 0 exactly. Therefore, what we can say? We can say 38 is not a perfect square. So by this successive subtraction method, we have checked that which number are perfect square or which are not. Okay. Now, how do we find the 36th odd number, right? So like the first odd number is 1, second odd number is 3, third odd number is 5, sixth odd number is 11, and so on, likewise will go on. So when we are subtracting, okay, for example, why we are finding the 36th odd number? Because it is given that find 36 square, and given that 35th square is this one. Okay, it means from 35th square we have to subtract and then we have to check. So now how can we find the particular odd number? For example, I need to calculate nth odd number. So for nth odd number, the formula is the nth odd number is 2n minus 1. You have to just remember this formula. Okay, so therefore if you put here n equals to 36, you will get it's 71. So by adding 71 to 1225, because it is 35 square. So if we add, we'll get 1296, which is the square of 36. Okay. So for 38, we have just now checked that whether it is a perfect square or not. So it's not a perfect square. Now, how many numbers lie between two consecutive perfect square? We have to find now number of numbers which lie between two consecutive perfect square. How can we see this? How can we find it? This we can easily observe from the pattern. And what we have observed from the pattern? We have observed that the number of non-squared numbers between n square and n square, n plus 1 whole square is 2n. Means, let's suppose we have to find how many non-square numbers are there between 2 square and 3 square. 2 square is what? 4. 3 square is what? 9. Between them, how many non-square numbers are there? So we know that between 4 and 9, there are 5, 6, 7, 8. So there are total 4 perfect square numbers. Let's check how we can find that. So here n square, the smallest number 1, which we have taken its square, we'll take that. So here it's 2. So 2 times 2, 2n. So 2 times 2 is 4. So the numbers which are non-square and coming between 2 square and 3 square is 5, 6, 7, 8. Okay. Now next, how many square numbers are there between 1 and 100? Or how many square numbers are there between 101 and 200? See, here we can easily calculate like this, we will calculate here. But you know, there is a pattern. What pattern? Basically, Like as we go to the large numbers, the number of square numbers are becoming smaller. Means between 1 to 100 we have 9 square numbers. Between 101 to 200 we have 4. Between 201 to 300 we have 3. Likewise, we'll go and when we'll check 901 to 1000, we'll have only one perfect square number, which is 31 square 961. So this is one pattern which we are finding here, right? So I hope you understood this one. Okay, right. So if you all understood till here, so let's clap. Let's enjoy for you that yes, you understood till here. Okay? Yes, very nice. Chalo. Now next, perfect square and triangular numbers. Oh my God, we have done so much, right? We have done so much. Like my mind is about to burst like bubbles. Is it? No, it cannot be. We have to study more. So next we are going to learn perfect squares and triangular numbers. Okay, so now here you know the triangular numbers means the number of dots which we use to form a square, triangle. So those are called triangular number. Now how these triangular numbers are related to the perfect square numbers, or how these triangular numbers are forming the square numbers? Now for this you can see sum of any two consecutive triangular number is always a perfect square. How? So as it was already mentioned previously that visuals are the best things to explain. So like for example, if I take 3 and 6, two consecutive triangular number, 3 and 6, 3 plus 6 is 9. 9 is what? 3 square. So how can we see that it is forming a perfect square? So now here you can see 3, first triangular number, and then 6, here's 6, right? So total 9. Now you can see it is forming a square. Similarly here 6, here 10. If I join them, you can see I'm finding 4 square, 16, right? Are you getting? So basically what we can say two consecutive triangular number, if we add, then we'll always get a perfect square number, right? Okay, now next, the master key. Now that we can identify a square, so how to find its root? Root means like what number should be multiplied with itself to get a square number. This is called its root. The area of a square is 49 square centimeter. What is the length of its side? So we know that 7 into 7 is 49 and 7 square is what? 49. 7 into 7 is what? 7 square. It's 49. So what we can say? We can say that side of the square with the area 49 square centimeter is 7 centimeter. It means 7 is called square root of 49. It means what? It means if I am writing y equals to x square, then x is the square root of y. Okay. So similarly, we have to find square root of 64. So which number is multiplied by itself to give 64? Tell me the answers. Now it's your turn. Now I'm not speaking, your turn. You have to tell. Yes, absolutely correct. If you multiply 8 by 8, or if you multiply minus 8 by 8, minus 8 by minus 8 will get 64. Okay. So the square root of 64 is plus 8 and minus 8. See children, whenever we find the square root, we'll get always two square roots. One is positive, one is negative. Here you can see root 64 plus minus 8, root 100 plus minus 10. So this is basically the symbol. This is the symbol of root, denoted by this symbol. It is called square root or root. But in this chapter, we will consider only and only the positive square roots. Okay, you have seen all these. this is also called the inverse of squaring. Finding the square root is what? Inverse of squaring. Now how can we find this square numbers? So the numbers prime factors reveal if it is a perfect square or not. How? So for that we have to do prime factorization. You can use factor tree or you can use long division, any method you can use to find the prime factors. As it is 324, we found the prime factors, divisible by 2 got 162, then again by 2, 81 by 9, 9, 3, 3, 3, 3. Okay, so like that 324 we got 2 into 2 into 3 into 3 into 3 into 3. So if I arrange it into two identical groups, what I will get? I will get 2 into 3 into 3, again 2 into 3 into 3. It means I can easily identify its root. You have to take that identical group, okay, which is copying, okay, which we are getting the two pairs. So here the group identical is 2 into 3 into 3. So if I multiply all these, we'll get 2 3s are 6, 3s are 18. So square root of 324 is what? 18. Now let's take one more example, 156. If I divide it by 2, I'll get 78. Again by 2, I'll get 39. And 39 by 3, I'll get 30. Now here you can see for this 2, I'm getting 2, but this 3 and 13 are unpaired. So as it is unpaired, 156 is not a perfect square. Right? Okay. Now, so this was one method using prime factorization. How can you find the square root of a number? Now for large number, how can we find root? Through logical estimation, right? Because see, this new book of CBSE, it is focusing more on critical thinking, logical thinking, right? So let's find out the square root of 1936 without prime factorization. So first step is bracket the number. It means we have to find the smaller number to this or lesser to this and greater to this square number, right? So basically we take the gap of 10 10. So 1936, it lies between 40 square and 50 square. 40 square is 1600, 50 square is 2500, right? 40 square, 4 square is 16, so 40 square 1600, 5 square 25, so 50 square is 2500, right? So what we have done, we have bracket this number. Now you have to check the last digit. Okay, so means here you got that yes, it's a square root. If we find, it will lie between 40 and 50. Now we'll check its last number. Last digit is 6, and 6 comes at the end of square of 4 and then the square of 6. So there are two digits. It means it's a square root. Either its square root will be 44 or 46, because between 40 and 50, the numbers which are ending with 4 is 44, ending with 6 is 46 only, right? Okay, so we have checked the last digit also. Now next, half the interval. Okay, so half the interval, it means the number here, it is 40 square, 50 square will come between 45 square. So 45 square is 2025. So we have half the number, and then we will arrange this given number 1936. You can say this number is coming between 40 square and 45 square. Now between 40 square and 45 square, so you can clearly say that it must end with 4, right? It means the only possibility is 44. So square root of 1936 is 44. So like that we can conclude it. Okay, so here till now, to find the square root, what you have learned, or to discuss about this, when we discuss about the square, what you have learned. See, you have learned first thing, how to identify that a given number is a square number or not. So it must end in 0, 1, 4, 5, 6, 7. If it has zeros, it must have even number of trailing zeros. Then what was its structural properties? That yes, every square and square is the sum of first and odd numbers. Or we can say that sum of two consecutive triangular number gives a square number. Now next, finding square root. So for finding square root, we have used two methods. First is prime factorization. group the prime factors into two identical sets and take one set that will be the square root. Second method, estimation method, bracket it, check the last digit and narrow the possibilities. Right? We have done. But sometimes see what happens, like we are getting a number which is not the exact square. It means what we say, which is not a perfect square, but still we have to like estimate its estimate its square root. How can you estimate? So for that you have to listen one story. Are you all ready to listen that story? Yeah. Okay, so here we go.
You know that feeling when you're stumped by a number that doesn't have a perfect square root? It kind of feels like a dead end. But what if I told you there's a really clever mental trick to get incredibly close to the answer? Well, today we're going to crack that code for estimating square roots, turning those tricky numbers into something you can solve in just a few seconds.
Let me set the scene for you. It all kicks off with a simple game between two friends, Arabam and Bijou. They're just trading numbers in their square roots, but one of them's about to throw a curveball that changes the whole thing. So, the game is all about square roots. The rules are super simple. One person says a number, the other has to say its square root. But, as you'll see, the game is about to hit a snag when the numbers stop being quite so neat and tidy.
Okay, so Arabam kicks things off. He says 25, and Bijou, without even blinking, comes right back with 5. Easy enough, right?
Then it's Bijou's turn. She throws out 81, and Arabam quickly volleys back with 9. They're both really sharp and know their perfect squares. The game is flowing, it's fast. But then Arabam hits her with this, 250, and just like that, the game screeches to a halt. Bijou is totally stumped.
And that's the big question, isn't it? There's no clean, whole number that multiplies by itself to get you 250. So what do? Arabam asks for the next best thing, a really close estimate. And this brings us right to the technique. See, the secret isn't to try and calculate the exact answer in your head. That's way too hard. The secret is to find the perfect neighbors of our tricky number. Okay, just a super quick refresher so we're all on the same page. A perfect square is just a whole number multiplied by itself. You know, numbers like 4, 9, 16, 25. You get the idea. These are going to be our landmarks. So here's the 3-step method Bijou can use. Step 1, find the perfect squares that are just below and just above your number. Step 2, find the square roots of those neighbors, which, you'll see, are always simple whole numbers. And finally, step 3, just see which of those neighbors your number is cozier with. Let's actually do this for 250. As you can see here, the perfect square just below it is 225, which is just 15 squared. The one just above is 256, or 16 squared. So right away, we know our answer has to be somewhere between 15 and 16. Now for that final step. Which one is it closer to? Well, think of it on a number line. 250 is only 6 away from 256, but it's a whopping 25 away from 225. I mean, it's clearly way, way closer to its upper neighbor. And just like that, Bijou's got her answer. She can confidently estimate that the square root of 250 is approximately 16. She's back in the game. Okay, now that we've got the technique down, let's apply it to a slightly different kind of problem. This isn't just a fun little game anymore. This is a practical, real-world puzzle. So, let me introduce you to Akil. He's got a square piece of fabric, and the area is 125 square centimeters. What he wants to do is cut the biggest possible square handkerchief from it. But here's the catch. The side length of his handkerchief has to be an integer, a whole number. He can't have a side that's, 11.2 centimeters long. So this time, we aren't just estimating, we're finding a hard limit. We use the exact same neighbor technique. The perfect squares around 125 are 121, which is 11 squared, and 144, which is 12 squared. Now think about it. Could Akil cut a 12 by 12 centimeter handkerchief? No way. That would need 144 square centimeters of cloth, and he only has 125. He doesn't have enough. And that simple logic gives us the solution. He has to go with the lower neighbor. The largest possible handkerchief he can cut will have sides of 11 centimeters, which uses up 121 square centimeters of his fabric. So what do a math game and a handkerchief puzzle really have in common? Well, they both show us that this estimation skill is about so much more than just getting close. It's about making sense of all those messy numbers that don't fit into our neat little boxes. The key takeaway here is this simple but really powerful technique. For any of those imperfect numbers, you just find its perfect square neighbors, get their easy-to-find roots, and then use those as your guide. It doesn't matter if you're estimating or finding a hard boundary.
And I love this quote because it sums it all up perfectly. Estimation isn't about being perfectly right, it's about being intelligently close. It's all about using logic to find an answer that's practical and actually useful.
And that's the real power of this skill. It's a tool you can now apply anywhere, from quick mental math to planning a real-world project. You have the tool now, so the only question left is, where are you going to use it next?
Yes, children. So I hope you enjoyed that story. Okay. So next is figure it out. This we will solve in our next video. So that's all for this video. Bye bye. Take care.